Magma is molten material inside of the Earth's crust, whereas lava is molten material on the surface of the Earth. Mafic magma is magma that has a low silica content and contains more dark magnesium and iron-rich mafic materials including olivine and pyroxene. Mafic magma has a high temperature range between 1000 and 2000 degrees Celsius. It contributes to its low viscosity. The viscosity is magma's resistance to flow. Felsic magma is higher in silica with minerals like quartz and orthoclase feldspar, which gives it a lighter color. Magma is found in different parts of the world with varying substances and volumes. The Hawaiian Islands are formed from mafic magma eruptions. In South America, the Andes Mountains were created with intermediate magma, which is a mixture of both felsic and mafic magma. Intermediate magma has a higher silica content, gas expulsion, and viscosity than mafic magma. It also produces andesitic rock. Volcanoes found underwater contribute to 75% of the annual output of magma. Divergent plate boundaries are also called mid-ocean ridges. The shape, style, and rate of the volcano is controlled by the rate at which the plates move apart. Magma starts its cycle inside of the Earth's surface on the upper part of the mantle. Magma forms through decompression melting, which is an upward movement of the Earth's most solid mantle, occurring where tectonic plates separate, called divergent boundaries. Decompression melting can also happen at mantle plumes, which are columns of hot rock that rise from Earth's high-pressure core to lower its low-pressure crust. Then magma will enter a process of convection, where less dense material rises and more dense material sinks. Magma is also created through flux melting, which occurs when water and carbon dioxide are added to rock. Then, the rock is able to melt at lower temperatures, which creates magma. The cooling rate determines the texture of the rock. As magma cools, specific cations and anions bond and form small crystal nuclei. The faster the cooling rate, the more nuclei that form. As the cooling rate determines the texture of rock, crystallization reflects the chemical's composition. Because of the large amount of crystals and the short amount of time for the crystals to grow, the result is a fine-grained rock, called aphanitic rock. On the other hand, magma that cools within the Earth's surface and endures a process of stalling is called ascending magma. This type of magma is plutonic and results in a coarse-grained phaneritic rock. The materials I used in my experiment were 4 jars with water, corn syrup, cooking oil, and honey. In order to test which liquid is most viscous, I placed a marble into each jar to see how fast it would fall to the bottom. The liquid that made the marble travel the slowest has the most viscosity. Here we see that honey is the most viscous and oil is the least viscous. To further my experiment, the liquid with the most viscosity is the most dense and will therefore be at the bottom of the glass. The liquid with the least amount of viscosity is the least dense and will be at the top of the glass. Again, we see that honey is the most viscous and oil is the least viscous.